Hey, good day, folks. In today's class, I'll be talking about chapter 8.2, and the topic will be sampling distribution of a sample proportion. All right. So first of all, we'll talk about why we need to study this, and then later on we will take one problem on this one. So if you can recall, in chapter 6, we talked about discrete probability distribution. Distribution. That's what we talked about. And in that one we use the by to solve problems on the discrete probability distribution, we use the binomial theorem. And after that, in chapter number 7, we talked about the continuous probability distribution. Continuous probability distribution. Now, if I wanted to convert discrete probability distribution into continuous probability distribution, then I need to study the sampling distribution of a sample proportion. Okay, basically what we are doing is, rather than applying the binomial theorem on this one, now we will apply the normal distribution graph. So how does a normal distribution graph looks like? This is how a normal distribution graph looks like. This is what I'm going to apply on our discrete probability distribution. For that, I will use the sample proportions. Now, when we talk about the sample proportion, there are certain terminologies which we need to understand. So first one is p hat. So this is proportion of success. Proportion of success for a sample. And capital P is proportion of success for a population. Now, again, same way as we were talking about sample and proportion, same thing. If for a sample, it will be represented by p hat. For population, it will be represented by capital P. And the formula for this one is success, number of success upon number of trials. Whoops, I don't know why I can't write it. Number of trials. That's going to give me p hat. And if it is a sample, if it is a population, then it will be number of success in the given population upon the number of trials in a given population. And other than that, you will also find a formula for the standard error for proportion, that is sigma p hat, which is equal to square root of np q divided by, well, not npq, pq divided by n. pq divided by n, and everything is under the square root. Now what is q? If p is the proportion of success, q is the proportion of failure. This one was success, proportion of success. This is proportion of failure. Q value will be 1 minus p. Q is 1 minus p. This will play the role of the standard error. Standard error. All right. Now, if you can recall chapter number 8.1, in that we used certain formulas. Let me just quickly open up my formula booklet. One of the formula which we used was z equal to x bar minus mu divided by sigma x bar. This was standard error. This was equal to sigma upon sigma. Whoops, again my pen stopped working. Sigma upon square root of n, and this was the mean of the population, which was same as the mean of the sample means, and this is sample mean, and this was the z-score. So now again we will find the z-score for this chapter also, but the formula will change to p hat minus mu p divided by sigma p hat, and mu p can be replaced by term p. So capital P, this was the proportion of sample, proportion, not sample, sorry, proportion of population, proportion of population, and this is proportion of a sample, and this is the standard error which we've already figured out. The value for this one is square root of p times q upon n. That's what this is. Earlier we used to have x bar in chapter 8, x bar, then the next thing was z, and then the oops, again I think I need to buy a new pen. Z, first of all x bar, and then z, and then the third thing was probability. Now we will have p, z, and probability. So these are the three things we will be working. This p is the proportion. Okay, I'll write it as p hat actually, and then from there we will find the z and the probability. Sometimes probability will be given, we will find the z, and then we might have to find the proportion of the sample. Okay, that's how the question's gonna look like. So I've given you the overview of the formula. Now I'm gonna take a question on this topic. So here it is a question on your computer screen. This question says, a Canadian study in 2017 found that approximately one in every three paramedics had a positive screening for the anxiety disorder. A random sample of 64 paramedics is collected. What is the probability that more than 40% of screening for anxiety disorder? Now, whenever you see a question like this, first thing should come to your mind is to select whether this question belongs to which chapter, because I've already told you that this question belongs to chapter number 8.2. So it's easy to figure out right now, but in exam, how are you going to figure out? So if you see a question like this, well, one of the hint will be you'll never be given standard deviation. Standard deviation value is not given to you. Another, the terms like average or mean will be missing. Average and mean will be missing. Whereas you will be given some sort of a proportion of a success or a proportion of a failure. Those things will be given. So for example, if I see here, not a direct proportion given to me, but I have to make a proportion out of it, that one in every three paramedics had a positive screening. So I can say population proportion is 1/3, which comes out to be 0.33. Now, a random sample of 64 paramedics is collected. What is the probability that more than 40% had the positive screening for the anxiety disorder? In this one, I'll put n value as 64. N is the sample size. And now I'll draw the diagram. So the diagram is going to look something like this. And as I told you, proportion of population will play same role as that of the mean. So right in the middle, I'll place the population proportion, which is 0.33. And now what is the probability that more than 40% had the positive screening for the anxiety disorder? So if this value is 0.33, p hat is 0.4. Now 0.4 will be on the right side, and it says at least more than 40%. more than 40%. So this is the section I'm looking for. I'm looking for this section. First of all, I'll find the probability correspond to this section, and then 1 minus that will give me the orange section. So z value will be equal to p hat minus p divided by sigma p hat. And to solve this question, first of all, I'll try and find the sigma p hat, which is p times q. This is not p hat, remember this thing, and this is q. So divided by n, this will be square root of 0.33 multiplied by 0.67 divided by 64. So if I were to do the math on this one, let me quickly open it on my calculator. So this value will be 0.33 multiplied by 0.67 and then divided by 64, and then if I square root this value, second function, square root second function answer, which is equal to 0.058. I will call it as 588. This is the value I got. Now p hat value is 0.4 and minus p value, which is equal to 0.33 divided by 0.0588. And if I were to do the math on this one, that will be 0.4 minus 0.33 equal to 0.07 divided by 0.0588. Divide this number 0.0588, that's gonna be 1.19 z-score value, 1.19. I got the value as. All right, so now the next step is correspond to this z-score. I will try and find out the value of probability. So if I go back in my z table and look at the probability correspond to the z value of 1.19, let me just quickly open it. This value of 1.19 will be 0.8830. So probability value for p hat less than 0.4 is equal to 0.88. See, my memory is so weak, forgot. 1.19, 0.8830. That is the value. So that is this pink section, 0.8830, and I wanted to find this section now. So probability that p hat is greater than 0.4, that will be 1 minus probability of p hat less than 0.4. That value will come out as 1.0.8830. That will be 1 minus, if I were to do the math on my calculator, 1 minus 0.8830, that's gonna be 0.117. Now, one thing I want to tell you, your answer in the answer book will be little different from the answer I got, because I kept the p-value up to 2 decimal places. So the value which I took was 0.33 here, and p-value was 0.4. Okay, so it's totally okay to get the different answer a little bit. because my position is different, some people may end up taking 0.3, and here if I take 0.4, your values will be a little different. So that's totally okay. I'm not going to mark it wrong. Okay. So that's how you're going to solve this question. Now, if I look into the part B of this question, less than 25%. So I'll just give the hint how to solve this one. It is directly saying less than 25%. So P value is 0.33 here, and P hat will be on the left hand side. P hat is 0.25, and I'm looking for less than 25% section. So this is the section I am scrutinizing. Now, how can I scrutinize the section? Again, same old story. Z value is equal to, first of all, let me write down, I'm looking for probability of P hat less than 0.25. That's what I'm looking for. And then to do that, I'll say Z score equal to P hat minus P divided by sigma. Sigma, the formula was sigma P hat. Oops, my pen is clearly creating a lot of problems for me. All right, now this is equal to, this is 0.25 minus 0.33 divided by this value I've already figured out from the previous part. It's not going to change, so I can 0.0588, 0.0588, that will be the number. Now I will leave it for you guys to solve this one. So find the Z value from here. From the Z, find the probability value, and that will be your answer. If I look into the part C, between 30 and 35%. So between 30 and 35%, again, I'm going to give you the hint how to solve this, and I'll leave it for you guys to solve that one. So this is 0.33. 30% will be P hat is equal to 0.30, and this value P hat will be equal to 0.35 on this side, and I am looking for this section. So what I'm gonna do, I will first of all find the probability correspond to this whole section. This is what I'm gonna find out, and then I will subtract the probability of this red section, this section, the red one. All right, and that's gonna give me the remaining of the section. That remaining section, I will color it with the blue now. Let me just thicken it up. Okay, so this section, then I will be able to find out. So how I'm going to write it? I will write it as probability is equal to 0.035, well, 30, less than P hat less than 0.35. That's what I'm looking for. That will be equal to probability P hat less than 0.35 minus probability P hat less than 0.30. Once you're going to do these steps, you will be able to get the answer for this one. 0.35 minus 0.33 divided by 0.0588. How did I find out? You can see it from the video also by going back into the video, or you can see it from here also. This is previous value, I'm copy pasting it because this value is not changing. And then whoops, then the second part for this one, it will be 0.30 minus 0.33 divided by 0.0588. This is Z1, this is Z2. Correspond to this, you will find the probability value. Correspond to this, you will find the probability value subtract those probabilities, that's going to give you the answer for the question. So hopefully you were able to understand how you can approach these kind of questions if asked in exam. So I wish you the best, and I'll see you with another video. Till then, goodbye.